Hi, in this video, we want to look at cofactors of a matrix. During the course of this video, we'll be looking at how to solve questions on cofactors of a 2 by 2 and also a 3 by 3 matrix. In previous videos, we've looked at how to find the determinant of a matrix. We've also looked at how to multiply matrices together. We've looked at how to add and subtract matrices from each other. So for the sake of this video, we won't be talking about the cofactors of a matrix. Now you should know that before you can find the cofactor of a matrix, you must ensure that the matrix is a square matrix, whether a 2 by 2, a 3 by 3, or so on. But note that you can only find the cofactors of a square matrix. Now, after that is said, let's say we're given, or what does it mean to find the cofactor of a matrix? So let's say we're given this matrix 4, 3, 1, 7, and then we're asked to find the cofactor. If we're asked to find the determinant, we simply do a product of the diagonals and subtract them from each other. That is the leading diagonal, the product of the leading diagonal 4 times 7 subtracted with the product of the backward diagonal. But this time around, we're looking for the cofactors, not the determinant. So we want to get the minus of each element. This element here, we are to write it according to the place values. 4 will correspond to A11, 3 will correspond to A12, 1 will correspond to A21, 7 will correspond to A22. Why am I writing it like this? Remember when we're talking about the position of elements of members in a matrix, this 4 is located in the first row and first column. This is the first row, and then this is the first column. That's why the first one signifies the row position, the second one signifies its column position. So if we've written it like this, we're now saying that each of these elements, A11 has a cofactor. Its cofactor will be its minor, or the product of its minor and its place sign. So whether it's positive or negative. Now this is quite easy. When you see a 2 by 2 matrix, you should know that this is how the place sign is. We're going to get see how we arrive at the place sign. So here will be positive, this will be negative, this will be negative, and then this will be positive. The leading diagonal is positive, while the backward diagonal is negative. So how do we arrive at that? So by simply writing all this outside. So A11, so we want to know the cofactor of A11 or the cofactor of 4. So we want to know the cofactor of A12, we want to know the cofactor of A13, we want to know, A21, not A13. Okay, and we want to know the cofactor of A22. All right, so let's start with A11. First of all, we start with multiplying the minor by -1. Now you can see these numbers they are saying here. This is 1 and 1. Add them together. Add the numbers they are saying at the subscript. So 1 plus 1 gives us 2. That will be the power of the -1. Then you go back to the matrix itself. Since this is A11, A11 belongs to the first row and first column. I want to strike everywhere in which A11 belongs to. That is, I don't want to take anything from the first row. I don't want to take anything from the first column. So that leaves me with 7. Because by the time I strike this area and also strike this area, the only number that will be free will be 7. So multiply this 7, that becomes the minor of A11. Okay, so let's do that of A12. For A12 again, -1, the power 2 plus 1, that will be 3. So write 3, then multiply it with. So where's my A12? 3. So A12 belongs to the first row and second column. So again, strike out the first row, strike out the second column. The only number that is left free is 1. So I write my 1 like this. Come to A21. A21 again, we do the same thing. -1 to the power of 2 plus 1, that's 3. To the power of 3. Then dot again. So 21, this is 21. A21 belongs to the second row and the first column. So I want to strike out the second row, that is 1 and 7, and then I want to strike out the first column. So the number or the minor that is free is 3. So that means 3 is the minor of A21. And lastly, again, -1, 2 plus 2, that's 4. So times, so A22, which is 7. So 7 belongs to the second row and second column. So if I strike out the second row, strike out the second column, the number that will be left free would be 4, and it's left for me to simplify. So simplifying this, so -1 to the power of 2, that's +1. So that's why we said the place sign is positive. Remember, we said the cofactors of a matrix, simply multiplying the minor with its place sign. Okay, so this one is positive. +1 times 7 gives us 7. Okay. A12. So when we cube a negative number, it returns a negative value. So -1 times 1, so that's -1. Okay. Again, cube a negative number, this will be -3. And lastly, uh, uh, take a negative number to a power of 4. In as much as the power is even, it will return a positive sign. Where the power is odd, it returns a negative sign. So this becomes 4. And then the cofactor of my matrix A, so I can write it cofactor of A, will give us another matrix entirely of the same order. So A11, I'm having my A11 to be 7, my A12 is -1, my A21 is -3, and then my A22 is 4. So I've written the cofactors of this matrix. So you can see how easy this is, writing the cofactors of this matrix. Okay, so let's quickly look at how to find the cofactor of a 3 by 3 matrix. So let's say we're given a matrix A, which is 3 by 3. So we're given, okay, let's try and take a question. Okay, 2, 4, 6, 1, 7, 3, 5, 2, 1. Okay, let's say we're given a matrix like this. And then, okay, so let's just try and make it much more interesting by introducing some negative numbers right here. Okay, so all right, so let's do something like this. Okay, now you can see that for this matrix, this is a square matrix, a 3 by 3 matrix. Now, if you want to write the cofactors first, why not do the same thing we did in the last when we're trying to get the cofactors of a 2 by 2 matrix. Let's write its unique identifier also outside, and then we can try to look for how to find the minor and also multiply its minor by its place sign. So since it's a 3 by 3 matrix, I know that the first number will be A11, this will be A12, this will be A13. Okay, and this will be A21, this will be A22, this will be A23, this will be A31, this will be A32, this will be A33. Okay, now this is the unique identifier. So I want to get the minor of all these unique identifiers. I want to get the minor of A11, A12, A13, A21, A22, A23, A31, A32, A33. So I want to get the minor and then form the new matrix. So, all right. So without wasting much time, let's try and do that. So let's start by writing A11, A12, A13, A21, A22, A23, A31, A32, and A33. So A11 is equal to what? So with what we did in the last video, of course, -1, 1 plus 1, that's 2. Now, you should know that this will be the place sign. This will be the place sign of the matrix. This is just for you to know. Okay, yeah. So, like we said, when the addition or summation of the subscript is even, and to return a positive sign. So this is negative, this is positive, this is negative, this is positive, this is negative, this is positive, this is negative, and then this is positive. So you can see that the diagonals are positive, while the what's it called? The other members are negative. So you can also use this as a guide. Subsequent videos, if we are solving questions on cofactors, we won't come using this long route. This is just to explain, so to let you know how we arrive at this sign. So this sign here is gotten by taking the addition of the subscript and squaring or applying it as a power to -1, and then multiplying it with the product of the minor. Okay, so without wasting much time, let's try and find the minors of all these elements that we've written outside. So the minor of the first one, A11 or 2, would be, so again, 2 belongs to the first row and first column. So strike out the first row, strike out the first column. So what do we have? I'm left with -7 -1. So multiply the -7 times -1 is +7, and then subtract it with 3 times 2, that's 6. So 7 minus 6, so that's 1. So I write my 1 here. So come to the next one, -1 again to a power of 3, because 2 plus 1 is 3. So again, this is 4. So strike out the first row, strike out the second column. So I'm left with 1 -1, 5 and 3. So 1 times -1 is -1. 5 times 3 is 15. So -1 minus 15. So that will be -16. So dot -16. Okay, all right. Now move on to the next one. Again, -1 or -1 to a power of 4 in the bracket of. So strike out the first row, strike out the third column. Then I'm left with 1, 2, -7 and 5. So 1 times 2, that's 2. 7 times 5 is 37, or minus 30, 35 rather. 7 times 5, that's minus 35. So 2 minus 35, so that will be plus 37. So write 37 here. So you have to be careful, especially when you're adding, so you don't make errors in the signs. Okay, so A21, we're coming to 1 now. So A21 belongs to the second row and first column. So strike out the second row, strike out the first column. So what have we left? It's 4, 6, 2, and 1. So 4 times minus 1, that's negative 4. So first of all, let me write minus 1 to a power of 3. Okay, now dots. So I didn't write my dots here. Okay, dots. Okay, so we can move on. We said 4 times negative 1, that's negative 4. 2 times 6, that's 12. So negative 4 minus 12. So that would be negative 16. Okay, and then we have, okay, for the next one, negative 1 to a power of 4. Okay, all right, so A22, so where's A22? Minus 7. So negative 4, negative 7 rather, belongs to the second row and second column. So second row and second column. So what do we have? We're striking out second row, and then we're striking out the second column. So I'm left with 2, 6, 5, and 1. So 2 times negative 1, that's negative 2. 5 times 6, that's 30. So negative 2 times negative minus negative 30. So that's negative 32. Okay, so you can see how easy it is. So we're just repeating the steps. So negative 1, 2 plus 3, that's the power of 5. Okay, dots. Okay, now A23, so this is A23, 3, A23. So A23 belongs to the second row and third column. So strike out the second row, strike out the third column. So I'm left with 2, 4, 5, and 2. So 2 times 2, that's 4. 5 times 4, 20. 4 minus 20, that's minus 16. So write your negative 16 here. Okay, so A31 is 5. So belongs to the third row and first column. So strike out the third row, strike out the first column. So I'm left with 4, 3, 6, and 7. 4, 3, 6, and 7. Okay. So 4 times 3, that's 12. 7 times 6, that's 42. 12, okay, but this is negative, so that will be 12 plus 42. 12 plus 42. So that will give us 54, I guess. Okay, so negative 1. 3 plus 1, that's 4. Dot 54. All right, so second to the last, A32. So belongs to the third row, second column. So strike out the third row, strike out the second column. So I'm left with 2, 6, 1, 3. So 2 times 3, so that's 6. This is the power of 5. So 2, 3, 2, 3, 1, 6. So 2 times 3, that's 6. 1 times 6, 6 also. 6 minus 6, so that's 0. All right, so lastly, okay, so what do we do? Okay, I think okay. We are right. Okay, so negative 1, this is 6 dots. Okay, so third row, third column. So I'm left with 2, 4, 1, and negative 7. So 2 times negative 7, that's negative 14. 1 times 4 is 4. Negative 14 minus 4, so that's negative 18. All right, so simplifying this, negative 1 to the power of 2, returns a positive value, just like what we said there, plus. Okay, so anything times 1 is still 1, so we have 1 here. So this is equal to, so this will be negative 1 times negative 16. Remember, this is negative 1 to the power of 3. So negative 1 to the power of 3 will still be negative 1. So times negative 16, that will be positive 16. So this is negative, okay, this is positive 37. Okay, this is negative times negative, this is positive 16 again. This is negative 32. This is positive 16. Okay, this is 54. This is 0, and then this is negative 18. All right, so after writing all this, the next thing is to write the cofactors of our matrix A. So writing the cofactors of A would now simply be equal to the new members that we've gotten. So A11 is 1, A12 is 16, A13 is 37, A21 is 16, A22 is negative 32, A23 is 16, A31 is 54, 0, and negative 18. So this is how we write we get the cofactor of a 3 by 3 matrix. I hope this concept is clear. So let's take one more example. So let's say we're given this matrix, and then we're told that the members of this matrix are 2, 1, 4, and negative 3. So I have to find its cofactors. So what do we want to do? So first of all, we want to write its place sign to So this is plus, this is negative, this is negative, this is positive. So remember, it's all about the minus. So you can write your what's it called, your matrix here. Then the minor of the first element, the first row and first column has to be negative 3. So negative 3 times positive 1. So that will still give us negative 3. Then the minor of 1. So of course it has this value of negative 1. So strike out the first row, strike out the second column. I'm left with 4. So this becomes negative 4. And then the minor of 4 here would become, so minor of 4, strike out this. Sorry about this. Okay. So strike out the first row, strike out the second column. So I'm left with 1. So, and this one has a negative value. So we have negative 1. And then lastly, the minor of negative 3 will simply be, so negative 3, strike out this and strike out what's it called, this first one. So I'm left with 2, positive 2. So this is the cofactor of my matrix A. Now you'll be wondering, I'm sure you'll have seen a pattern. Like, don't you think there's a shorter way to do what's it called, to find the cofactors? What if you swapped the diagonals? You swapped the what's it called, the backward diagonals and negate them, and then swap the leading diagonal. So are you going to have this thing too? So let's try another example and see whether that pattern works. We're going to be using that pattern first before this thing. So what I'm saying is you should have swapped 2 and negative 3 in such a way that you just write your what's it called, your matrix like this. So swapping them, we have negative 3, we have positive 2, and then negate this one, and also you swap them after negating. So this will be negative 1 and this will be negative 4. So like you can see this pattern. So let's see whether maybe it's just a coincidence, or perhaps it works for most questions or all questions. So C, so let's say we're given another matrix C, then we're told that matrix C is given as 4, 2, 5, 3. So this time around we want to use this. So you get, so the leading diagonal, you swap them, you just swap them. So the cofactor of matrix C would be given as, okay, so swap the leading diagonal. So this becomes 3 and 4, okay? And then swap the backward diagonal. So this is 2, but negates them, 2 and negative 5. So let's see if we go through the long process, whether we actually arrive at the same thing. So for this one, the minor of C, of matrix C, is 3, and 3 has a positive value, isn't it? So write 3 here, okay? For 2, 2 has a minor of 5, so the place value is negative 5, so we write negative. So for 5 is 2, negative 2, so negative 2. Y for 3 is 4, so we have this, we can say. So we've seen how to what's it called, find the cofactor of a 2 by 2 matrix, the long method and the short method, if you think it is short indeed. So in our next video, we'll be looking at how to find the adjoint of a matrix. So how to find the adjoint of a matrix. So do well to stay tuned. If you want to find the adjoint of a matrix, then you are able to find the inverse, or if you can find the adjoint of a matrix, so that definitely you'll be able to find the inverse of said matrix. So stay tuned. Do well to like the video, share it to your friends that are preparing for WAEC, JAM, GCA, and even in first years in universities, because you still take matrices and complex numbers in your first year in the uni. So do well to share with them. Thank you for watching, and bye bye.